Hello everyone, welcome to Learn Data Structures and Algorithm in Python course. In today's lecture, we'll be solving another problem on recursion. So what is this problem? It is called follow the knight. So first, assume you are playing a chessboard, okay? You are playing chess, you are given a chessboard and a knight is placed at a certain position, okay? Let's say the position is 3 comma 3, okay? Means row is 3, column is 3, okay? Then you will be given an integer k, let's say k equals to 1. Then you have to tell after kth move where this knight should be positioned at. Means, so how knight actually moves? Knight moves in 8 direction. First direction could be first vertically 2 places, then horizontally right at 1 place, okay? So this would be one position, okay? Then vertically 2 position, then horizontally one position, that could be one position, okay? Then then horizontally 2 position, vertically one position, that could be one. Then horizontally 2 position, vertically down one position, this could be one. Then horizontally left 2 position, then vertically one position. Then horizontally left 2 position, vertically down one position. Then vertically two, then horizontally one position, same vertically two, horizontally one position. Means knight can move in 8 different direction, right? So here, if k equals to 1, means after one move, this knight should be positioned at 8 different position, right? 8 different position. So in this problem, you have to tell how many positions knight should be placed after this kth move. So here the answer would be 8. Okay, here the answer would be 8. Let's say for different, let's say the knight here is positioned at different position. So here the position will be, let's say 2 comma 2, right? 2 comma 2. So and let's say k equals to 2. Okay, k equals to 2. Now let's say after two moves where the knight should be positioned at. Okay, let's try. So first could be vertically top here, then here one, then from here also it could move in 8 different direction, right? So from here it could be moved to here, or it could be move here, right? Then it could be move here, and it could be move here, right? Then it could be move here, it could be move here, okay? This is one. Then from here it could be move here, it could be move in the same position, okay? So this is one possibility, right? So after two move it could be positioned at 1, 2, 3, 4, right? So we'll not consider these things because these are outside of our board, right? We'll not consider them. So this is for one position. Then if we consider another thing, so let's say it was initially from here, right? So if we take from here, so if we tell them this, is this valid? No, it's not, right? So again, so if we consider from here, like from here to here, this is one, this is also one, right? So other side, then this could be one, right? This could be one. So here three position, okay? Then what are the different approaches? Okay, okay. So here we have done. So then it could be move, and this is one move. Then after from here it could be moved from here to here, one, here to here, two. So from so here it could be outside, okay? Then from here to here it could be one. Then from here to here it could be one. Then from here to here it would be one position. From here to here it could be one position. So there are different position possible, right? So from again, if you try from different, from here this is one position, from here also it could be moved from here to here, or it could be moved from here to here, it could be moved from here to here. So there are many possibilities, right? There are many possibilities. What you have to calculate, so you have to return in the chessboard how many positions could be possible after kth mode, right? So here if you say, so we have to basically calculate how many places are possible that knight could stay after kth mode. Now let's say how we can solve this problem. Okay, so first thing we have considered that knight could be moving 8 different direction, right? So 8 different direction means how will we calculate? So let's say initially the position was 2 cross 2, means there will be some row value, there will be some column value, right? There will be some row value, there will be some column value. Now tell me, after one move, what will be the position of row and column? One possibility could be row will be incremented by 2 and column will be, let's say, decrement by 1. Same, row is incremented by 2, column is now this time increment by 1, right? This one. Then let's say row is decremented by 2 and column is also decremented by 1. Then row is, let's say, incremented by 2, column is sorry, not incremented, that we have already taken. So row is, let's say, decremented by 2 and column is incremented by 1. Then again what will happen? Let's say this time row will incremented by decremented by 1 and column, let's say, incremented by 2. Same, row will decremented by 1 and column will decremented by 2. Okay, then row will incremented by 1, column, let's say, incremented by 2, then row is incremented by 1, then column, let's get decremented by 2. So there are 8 ways that knight could move, right? So there are basically 8 direction. So what we have to do, we have to use recursion for this. Then what will check once we have a row value and column value. Let's say once we have a row and column value, so first thing what we have to check, first thing we have to check, are we going outside of this chessboard? How we can make here? So let's say index from 0 to 7, right? So if we the row exceed from 0, that means if we get row value -1 or -2, like that, or let's say 8 or 9, that means we are outside of this chessboard, right? Similarly for column also, if we get column equals to -2, -1 or 8, 9, that means for that we have to return from here, right? We will not do anything. So first base case would be, so if this row is less than 0, or column less than 0, or row is basically greater than 7, right? What is the length of this board? And let's say column is greater than 7, then what we'll do, we'll just simply return from here. This is one of our base case. So this is basically base case. So base case number 1. Then what is the next case? So next thing we have to check for k. So if k equals to 0, that means we don't have any move, right? We have completed, right? Then what we'll do, if k equals to 0, then that means we have reached to our expected point, right? Then what we'll do, once we got there, we'll change this cell value from 0 to 1, right? Once we get there, we'll change the value from 0 to 1, right? So what we'll do, let's take it as board. Okay, we'll consider this as 2 cross 2 matrix, right? So not actually 8 cross 8 matrix, right? We'll consider this board as 8 cross 8 matrix, where 8 is the row and 8 is the column. So what we'll do, so board of row and board of col will make it 1. Okay, this is next thing. And then what we'll do, we'll just return from here. Okay, this is second base case. Otherwise what we'll do, we'll move our knight. Let's say we got k equals to 1, right? K equals to 1 or k equals to 2, whatever. That means we are not reached at our ultimate position, right? The ending position. Then what we'll do, so if k is not equals to 0, so I'm writing here, let's change the color. Then we'll just call this function again. So let's say the name of the function is follow knight, right? Follow knight. Okay, so we'll call this function again, and this time what we'll do, so let's say it was initially row and column, right? So this time we'll move our knight by, so first row would be, will incremented by 2, and then column decremented by 1, right? Column decremented by 1. Similarly for second time, so then move k, same, row plus 2, then column minus 1, sorry, plus 1. So all 8 position will be moved. Okay, then at last what we'll do, we'll check the board again. So board is nothing but a true equals to matrix, right? True equals to matrices. At last what we'll check, will iterate over this board, this row by row. And what will check, how many ones are there, so one means where the knight is positioned, that means that is one. Once we get to this expected position, here we make this cell as 1, right? Cell as 1. Then at last, if we count how many 1 is there, that is our answer, right? That is our answer. Let's say at last we get count is 10, so that will be our answer, right? So this is the approach. Let's see how we can code this. Let's consider a board as 8 cross 8 matrix, and initially all the elements are 0. Okay, now what we have to find, number of position, right? So let's create a function def find positions, and what will take, it will take the board, right? And it will need the position of row and column, right? Row position and column position, and value k. Okay, then what we'll do, we'll create another function. Let's name it as def follow the knight. Okay, and similarly it will also take board, current row, current column, and integer k. Okay, first what we'll do, we'll call this function right here. We'll call this function follow the knight, then pass this board, whatever row we get, column we get, k we get. Then after that what we'll do, so we'll take a count variable. We have to count number of ones here, right? So count, basically initially it will be 0, then we'll be iterating over this matrix. So for, let's say, row in board, then for element in this each row, row r, if this element equals to 1, then what we'll do, we'll increment the count by 1. Okay, and at last we'll be returning this count. Okay, this is simple. First we'll call this function. So let's write it. First thing, we have to check the base case, right? So this case, so if row less than 0, column less than 0, so write it, if row is less than 0, or let's say column is less than 0, or row exceeds, if row is greater than or equals to length of this board. Okay, where the board, or column also exceed the length of this board. Okay, then what we'll do, we'll just simply return, we'll do nothing. Otherwise, if we check if k is equals to 0, then what we'll do, we'll make this cell, so board of row and of current column, we'll make this cell to 1, right? Then we'll just return from here. Otherwise what we'll do, we'll call this function again, but this time we'll decrement the k value by 1, right? And we'll change the row and column. We'll be moving the knight in 8 different direction. So let's write it. So follow the knight, then it will take initially board, then row, some row value and column value, right? And this time k will be decremented by 1, so k will be k minus 1, right? So we have to write 8 different things here. Okay, so first time we'll increment the row by 2, okay, and decrement the column by 1, let's say. Okay, the second time we'll increment the row by 2 and increment the column by 1, right? And next decrement the row by 2 and decrement the column by 1, and decrement the row by 2, and now this time increment the column by 1, right? Now this time decremented row by 1, but increment the column by 2. Again decrement the row by 1 and decrement the column by 2. Then increment the row by 1, decrement the column by 2. Then increment the row by 1, and this time increment the column by 2. So first thing, we are incrementing row by 1, then minus 1, yeah, minus 1 plus 1, yeah, first increment was decrement. Okay, that's fine. Okay, and so that is it, I think. Yeah, that is it. Now let's create a result variable. So let's say result, and result will be calling this function called find position. Okay, we'll pass the board here, then any random row and column. Let's say initially pass 0 0 means the first position, initial position, okay, at the top. And let's say pass the k value as 1. Okay, k value as 1 means we want to move knight by 1 moves, right? Then last print the result. Okay, print the result. Now let's see, let's run the code. Here you get 2. So let's check it. Okay, so let's say let's remove this. Okay, so let's say knight was initially here. Okay, so after one move it could be go from here to place. So in the above it couldn't be go there, so here is one position. Okay, now in the left it is not possible, in the top it is not possible. Then so in the vertically downwards it will go to two place, then here it will be one place, so answer will be 2, right? Now let's see for this position, this is 3 cross 3, right? So after one move it will be in 8 different direction, right? So it would be here, 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 right? So let's check it out. So for 3, so row is 3 when column is 3, the expected result and the move is 1. So after one move the result would be 8, right? So let's check it out. Yes, the result we got 8. Now if we increase the move, if we do 2, then let's say 27. If we also increment 3 or 5, so then also it will increment 32, right? So I hope now you have understood the problem.